Hello everyone, in this video we will explore topic 7.9 AB Calculus BC topic Logistic models with differential equations. Logistic growth. In AB Calculus, the exponential growth model was derived from the fact that the rate of change of a variable is directly proportional to the value of y. When using the differential equation, dy over dx equals k times y, and its general solution y equals c times e raised to the kt. You may notice that the exponential growth is unlimited. However, when describing a population, there often exists an upper limit L, past which growth cannot occur. This upper limit L is called the carrying capacity. It represents the maximum population y of t that can be sustained as time t increases. A model that depicts this type of growth is called a logistic differential equation. dy over dt equals k times y times 1 minus y over L, where k and L are positive constants. The logistic differential equation of the form dy over dt equals k times y times 1 minus y over L results in a solution of the form y equals L over 1 plus b times e raised to the negative k times t. Alright, so we have the formula logistic differential equation form is going to be this one, and logistic growth equation form is going to be this one. In either form, L represents the carrying capacity right here, L right here, and L right here should be the same, or upper limit of the logistic growth equation, which is the maximum. Alright. A logistic growth curve increases the fastest when the curve reaches half its carrying capacity L. Alright, let's take a look at the first example. The differential equation of a logistic growth model given by dy over dt equals k times y times 1 minus y over L has a solution of y equals L over 1 plus b times e raised to the negative k times t, right? Find the solution to the logistic growth model for the differential equation dy over dt equals 2 times y times 10 minus y with the initial condition y of 0 equals 1, alright? So, first you need to write this one right here in this form. So how do we do that? We need to factor 10 out, right? Because we look at the formula right here, we see that this one is 1, this one is 10, right? So I have dy over dt equals, now factor 10 out, does that mean I have 20y, right? Times 1 minus y over 10, right? So then I can conclude that this one is L, right? Look, L right here equals 10. And from this equation right here, I can conclude that K equals 20. Right? Look at this one right here. KY, this is 20y, so K equals 20, right? So I substitute this guy over here. So I have y equals 10 over 1 plus b times e raised to the negative 20t, right? Now I need to use initial condition right here to solve for b, right? So I substitute this guy over here, right? So I have 1 equals 10 over 1 plus b times e raised to the negative 20 times 0, right? So this guy becomes e raised to the 0 is going to be 1, right? So it's going to be 1 equals 10 over 1 plus b, right? So then 1 plus b equals 10 and b equals 9, right? So finally you have the answer. It's going to be y equals 10 over 1 plus 9 times e raised to the negative 20 t, right? So the answer must be B right here. Now let's move on to example number 2. The number of phytoplankton specimens in a laboratory setting at time t is increasing according to the logistic growth model. Which of the following statements could be true? Alright. So we need to identify the keyword. The keywords say the logistic growth model. Alright, so we're going to explore every single choice right here. Choice A. B of t equals 1780 over 1 plus e raised to the 0.035 t, right? Look at this one right here. Exponential is in the denominator, right? But this guy is positive, right? So if it's positive, it does not represent the growth model, right? So we need to exclude this one. Now, answer choice B. This one does not represent the growth model. It does represent the normal exponential growth, which is right here. Alright, so we're gonna exclude this one. Now, answer choice C. The second derivative of the function is positive. It tells us that the function is concave up, right? So it does not represent the growth model, right? We need to exclude this one. Now, answer choice D, we need to do backward, right? The logistic growth model is given by the formula right here. Alright, so we're gonna remove the antiderivative both sides. Right? So it's going to be dp over p times 1780 minus p equals 0.035 dt. I'm going to bring dt down and this one up over here. So it's going to be dp over dt, right? Equals 0.035 times p times 1780 minus p, right? Alright, I'm gonna factor 1780 out. So this guy turns out to be dp over dt equals 0.035 times 1780 times p times 1 minus p over 1780. Alright, this one actually the logistic growth model, right? It's going to be in this form. dy over dt equals k times y times 1 minus y over l, right? K equals this one right here. Alright, so the answer must be D. Now, let's take a look at example number 3. The spread of an infectious disease to workers on a large floor of an office building is modeled by the logistic equation P of t equals 800 over 1 plus 16 times e raised to the negative 0.5 times t, where t is the number of days and P of t represents the number of infected people. The graph of P of t is shown below. What is the number of infected people when the rate at which the disease is spreading is the greatest. Now we're going to take a look at the notes right here. A logistic growth curve increases the fastest when the curve reaches half its carrying capacity. Carrying capacity is the value of L right here, right? So we're gonna look at this one right here. Carrying capacity is 800, right? So you're gonna take 800 divided by 2. You're gonna get 400, right? So the answer is C, which is right here, 400, right? The maximum is right here. Now let's take a look at example number 4. The rate at which the natural gas is being extracted from an underground reserve at time t satisfies the differential equation dg over dt equals 0.04 g times 1 minus g over 64, where g is measured in thousands of cubic feet and t is measured in weeks. For what value of g is the extraction rate increasing the fastest? Alright. Now example number 4 is similar to example number 3. Alright. So you're gonna say that the extraction rate is increasing the fastest when the model has reaches half its carrying capacity. Right? Now this one is the carrying capacity by using the formula right here. Right? L right here. Now, before you're going to use the formula, make sure you need to convert this one to this form. Right? Make sure you have one right here. Right? So you observe that this one right here, you have one right here. So it's going to be exactly that form, right? So L equals 64. You're going to take L divided by 2. It's going to be 64 divided by 2. It's going to be 32. The answer must be B. Now let's take a look at example number 5. A conservation organization releases 30 pandas into a preserve. After 3 years, there are 50 pandas in the preserve. The preserve has a carrying capacity of 150. The growth rate of the panda population is dp over dt equal k times p times 1 minus p over l, which has a solution p equals l over 1 plus b times e raised to the negative k times t. Alright, so this one already in the original form, right? Now we need to summarize the problem. Alright, so from this one we have the first order pair is going to be at t equals 0, it's going to be 30 pandas released, right? The order pair should be t comma p, right? Now the second order pair is going to be right here after 3 years, which means t equals 3. You have 50 pandas, right? Now the carrying capacity is 150, which is L. 150, right? Now find L. L equals 150, right? Now question B. Find B. We're going to use order pair right here. Alright, so we're going to substitute this guy over here. So we have 30 equals 150 over 1 plus b times e raised to the negative k times 0, right? You always use the initial point right here, which means initial condition, to solve for b, right? So e raised to the 0 equals 1, right? So this guy turns out to be 30 equals 150 over 1 plus b, right? So 1 plus b equals 150 divided by 30. It's going to be 5, right? So b equals 4, right? Now let's move on to question C. Find the exact value of k. Do not write as a decimal. Alright, so we're going to substitute b back over here. And we're going to use the order pair right here, right? So we have the formula p equals L over 1 plus B times e raised to the negative k times t, right? Now, since we're going to use the order pair 3, 50, right? This one is t, this one is p, right? Now we have the carrying capacity L equals 150, right? Then we have B equals 4. We substitute the whole thing right here into this equation right here to solve for k, right? So I have 1 plus 4 times e raised to the negative 3k equals 150 divided by 50 is going to be 3, right? So then you have 4 times e raised to the negative 3k equals 2. Divide both sides by 4, so e raised to the negative 3k equals 1 half, right? Now take natural log both sides, so I have negative 3k equals natural log of 1 half, right? So k equals negative 1/3, natural log of 1 half, right? Or you can simplify this one, it's going to be negative 1/3 times natural log of 1 minus natural log of 2, right? So it's going to be natural log of 1 equals 0, right? So it's going to be 1/3 natural log of 2, right? Either this one or this one acceptable, right? Now question D. Write a model for a painter population in terms of T, right? So we have P of T, right? Substitute back over here, right here, equals 150 over 1 plus 4 times e raised to the negative 1 the natural log of 2 all together multiplied by t. Now let's move on to question E. Use the model to estimate the painter population after 12 years. So we're going to use this one right here. So we have P of 12 equals 150 over 1 plus 4 times e raised to the negative 1 over 3 natural log of 2 times 12, right? Alright, now we're going to put this one on the calculator. We're going to hit add calculator. The answer is 120. Alright, let's move on to question F. Find the limit of the model as t approaches infinity. Alright, so we're going to copy this model over here. Alright, now we're going to take limit both sides when t approaches infinity. Now when t approaches infinity, this guy right here approaches 0, right? So this guy turns out to be 150 over 1 plus 4 times 0, right? So it could be 150. This one is the final answer. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.